lot of terminology associated with the graph of a function. Many of the terms have names that are descriptive, but still work is needed to master the ideas. So first we're going to look at this function. It's at an interval. Remember, interval means that it's in between 2 points. We're looking at the x's, so that's going to be your horizontal line. And you notice that it starts at -7 on the left-hand side and stops at +7 on the right-hand side, and those are consistent with the numbers in the interval. So the first question is find the maximum and minimum. Maximum is obviously the highest point. The maximum is when y equals 1, 2, 3, 4, 5, 6, 7. And the minimum is when y equals -1. The other part that it's saying is state the values of x where they occur as well. So for the maximum, that was when x was -1, y was 7. And for the minimum, that's when x was -1, 2, 3, 4, 5, y was -1. So what is the y-intercept of the function? Well, the y-intercept of the function is where it crosses the y-axis. The y-intercept is y equals 6. It cannot have more than one y-intercept because x cannot repeat. And the y-intercept is always when x equals 0. So it cannot have more than one y-intercept because x cannot repeat. So give the x-intercepts of the function. Well, the x-intercepts is where does it cross the x-axis? Where this crosses the x-axis is 1, 2 places. That's when x equals -1, 2, 3, 4, 5, 6, and when x equals -4. So that's where y equals 0. What does x equal? You could also write those as coordinate points. It's -6, 0 and -4, 0. So would you characterize the function as increasing or decreasing on the domain interval of -5 to -1? So we are looking from left to right. Does it increase or decrease? Well, that one increased. If you're looking at the paper in front of you, you would see that it was going up from left to right. One additional interval over which the function is increasing and one which is decreasing. So remember, we're looking at x for both of them. And let's find another one where it's increasing. From 2 to 4, it increases, and it decreases from -1 to 2. You could use or equals to if you would like. It's not always necessary. I usually skip it because I can't see close enough to see if it really does include those numbers. All right, so the following points are known as turning points. Each can be classified as a relative maximum or relative minimum. The relative means that it is a peak, but it may not be the highest peak or the highest vertex, and it may not be the lowest minimum either. So -5, -1 is going to be a relative minimum. -1, 7 is going to be a relative maximum. 2, 2 is a relative minimum, and 5, 5 is a relative maximum. So let's get some more practice with piecewise defined functions and mix in our function terminology while we're at it. So consider the piecewise linear function given the equation f of x. So when x is less than or equal to 1, you use x plus 3. And when x is more than or equal to 1, you use 6 minus 2x. You'll notice that both of them include 1. That means that the answer for 1 will be the same either way. So first we're going to decide which ones are less than or equal to 1. Well, less than or equal to 1 is from -4 to 1. And then the ones that are more than or equal to 1 is going to be 1 to 4. So -4 through 1, you're going to use x plus 3. So -4 plus 3, -3 plus 3, -2 plus 3, -1 plus 3, 0 plus 3, and 1 plus 3. So your coordinate points are going to go -4, -3, -2, -1, 0, and 1. So when x is -4, y is -1. When x is -3, y is 0. When x is -2, y is 1. When x is -1, y is 2. When x is 0, y is 3. And when x is 1, y is 4. So we're going to go ahead and plot those points. So at -4, it's -1, -3, 0, -2, 1, -1, 2, 0, 3, and 1, 4. Now we're going to look at the other equation, 6 minus 2 times x. So if we do 6 minus 2 times 1, 6 minus 2 times 2, 6 minus 2 times 3, and 6 minus 2 times 4. So 6 minus 2, 6 minus 4, 6 minus 6, and 6 minus 8. So for 1, it's still going to be 4. So 1, 4 is still our answer. Then 2, 2, 3, 0, 4, -2. So if we plot those points, we now have a piecewise function that looks like this. So let's state the zeros of the function. The zeros is where it crosses the x-axis. So the zeros is when x equals -3 and x equals +3. The y-intercept is where it crosses the y-axis. It crosses the y-axis up here. It's kind of hard to see on the screen in front of you, but you'll see that it crosses at y equals 3. So give the interval over which the function is increasing. So the function is increasing. Actually, I'm going to use green for this because green is where it's increasing. From -4, because remember you used the x's on this, all the way to 1. It includes -4 on this one because that's where we start. We know for sure. But it doesn't quite equal, it's not or equal to 1 because the 1 is shared on both of them. So now our next one, it's where it's decreasing, and it decreases from the 1. And again, since the 1 is shared, we can't say that that is decreasing. But we do include +4. Give the coordinates of the turning point and classify it as either relative maximum or relative minimum. So the turning point was at 1, 4, and that is the relative maximum. Use a graph to find all solutions to the equation f of x equals 2. Remember, that is the same thing as y equals 2. So where y equals 2 is right here and right here, which is x equals -1 and x equals +2. And the last question on this part, state the interval over which this function is positive. So we want to know, where is it positive? So where is it above the x-axis? So it's above the x-axis. We're going to go ahead and keep the x. We don't include -3 because that's on 0. And we don't include +3 because it's on 0. But everywhere that x is between -3 and 3, the graph is above the x-axis.